Welcome to the lecture series 2 on the topic Foundations of Algebraic Structures and Number Theory. So let us move on to the concept of rings in this concept. So and ring is an algebraic structure equipped with two binary operations. So when we say binary, we talk about an operator where two operands are connected. So typically addition, multiplication that satisfies certain axioms comes under ring concept. So as I said, ring is an algebraic structure. So such kind of operators like addition, subtraction are included into this. So as we discussed in the previous lecture, there are certain properties that satisfies the concept of groups. So here even we have certain things which is connected with groups, that is closure, associativity, identity, and lot more into this. So we'll in the further discussion we'll talk about these things in rings. So exploring rings, as I said, a ring is an algebraic structure equipped with two binary operations. Typically it will be like addition and multiplication. Okay, so when we talk about its properties, first of all we talk about closure. Closure means that the result of adding or multiplying any two elements in the ring is also present in the same ring, similar to groups. And also associativity. Associativity applies to both operations, that is addition, multiplication, ensuring that the order of operations does not affect the result. And the third one is identity. So there are identity elements for both addition and multiplication, though not every ring has a multiplicative identity. There is a note here, there is a remark you should understand. Not all the rings have multiplicative identity. And the next one is distributive property. Distributive property connects the two operations, ensuring that multiplication distributes over addition. Okay, so rings are foundational and fundamental, and it forms a basic like how groups are in algebra, providing a framework for every mathematical operation, mathematical structure, and other things, other properties related to algebraic structures. Okay, so even we can say like an example, like there are some common examples including integers, rational numbers, real numbers, and polynomials, certain things of polynomial structures which could be brought in rings, where these kind of properties can be studied in the ring theory. Okay, so further on, like how we split, how we what to say, in set theory you would have learned, like if there is a set, if there is a universal set, or if there is a whole set, again you can break the sets into multiple subsets. Similarly here also groups can be taken to the next level as subgroups and also subrings. Subgroups and subrings, so the thing is, in subgroups and subrings, they follow the properties to be followed according to the groups from where they come from. Okay, so that is the very important idea. So when you talk about subgroups, subgroup is a group, or it can be a subset of a group that is itself a group under the same operation. It can be addition operation, it can be a multiplication operation. It may satisfy the group axioms of closure, associativity, identity, and invertibility. And you can talk about even we can talk about cosets. These are the partitions of a group created by a subgroup. For example, if H is a subgroup of G, then you can say we can find some cosets of H in G, okay, in the set. So I could tell, like if there is a group, we can have a subgroup. Again in that subgroup we can have cosets. Okay, similarly even we can have some kind of sub ideas in rings also. We call it as subgroups. Similarly, a subring is a subset of a ring that is a ring again itself by itself and under the same operations, what already followed by the ring. Okay, so it must include the additive identity and it must be closed under addition, subtraction and multiplication. So subgroups and subrings are essential in understanding the structure and properties of larger or universal or whole groups or bigger groups, the overall groups and overall rings in the given discussion. Okay, so thank you for listening this lecture 2.